Hello everyone, my name is Tom Cook and I'm the Primary Maths Leader. I'd like to welcome you to our parent engagement on supporting maths at home. And the aim of this is to give you a few top tips and ideas for supporting your children in their maths development outside of school. There's going to be 5 parts to this session. First one is going to be looking at some practical maths activities that you can do at home. The second one will be online support. Then we'll talk about times tables. We'll look at number bonds, which is a big focus in Key Stage 1, and then a tip particularly for Key Stage 2 people, which is called same difference subtraction. Now, before we begin, my first top tip is to remember to learn with your child. Not just thinking of yourself as a teacher, but you are the facilitator of fun learning experiences, which are meaningful and memorable. The minute you start thinking, oh, well, they haven't got this concept and they need to understand it by then, and you're getting stressed and then they get stressed, the relationship breaks down. So please remember to learn with your child, not just to teach them. And if you find maths difficult, it's absolutely okay, because there is always time to learn and develop. Be a role model for your child. Please, please, never say in front of your child, I was never any good at maths at school. Because that puts an idea in their mind that, well, my incredible parent wasn't great at maths, so I don't need to be great at maths, so why do I need to put the effort in? But we need you to be that role model that shows them that the learning never stops, and there's always time to build a relationship, to deepen your knowledge, and to become more confident. Being with your child when you are learning is always more memorable and meaningful, and it will be a lot more fun for them. So as much as possible, try and find time to learn with them and create some brilliant opportunities to discuss maths together. So first, let's talk about being practical with our maths at home. And I find, particularly at school, anything that makes maths practical makes it more fun. And at home, it turns maths into a real life concept, and children will see how it is part of our daily lives. So one of the first ways you can start at home, which is one of my favorites, is cooking. Now, it involves all the skills you can see here on the screen: measuring, looking at different units of measure and discussing those. Estimating is such a vital maths skill. Scaling recipes for fewer or more people. As much as possible, involve your children in cooking. And if they're not so keen, ask them what they want to cook. Put it in their hands. You can also then get them to come shopping with you for the ingredients that you need. Tell them, well, we need all the things on this list. How much does each one cost? How many items do we need? Do we have enough? Do we have anything in the cupboards that we can use part of? Will we need to get some more? How will we know? Also involved with shopping is that aspect of money. And you could maybe decide, well, here's the budget for the day. Can we get everything we need? At the end, older children could look at the receipt. How much have we spent in total? And how many items did we buy? So what's the average cost we've spent on an item today? There's so much that you can do involving cooking and shopping. Gardening and DIY are also fantastic activities. If you are building a new flower bed, if you're painting a room in your house, you can think, well, do we have enough material already? How much paint do you think we'll need to cover this wall? Ask your children to draw out plans and put on measurements. If they want to redesign their bedroom, get them measuring the bed, the tables, the chairs that they want. Where can they go? Drawing mathematical representations is such an important skill for many of the careers that lots of our children might want to go into. Time is also very important, and you can discuss this all the time, if you excuse the pun. If you are deciding to go out to the cinema, get them to look at the timetable. What time is the film? How much time does that give us now until we need to leave? How long does it last for? So timetables are really important. What time do you get home from school? How much time does that leave you to do what you want to do before dinner, before bedtime? Get them to estimate again, get them to measure and look at different types of clocks. I think in the modern day, we are very reliant on setting alarms and on our phones so that we, I guess, rely on those more than we would have done previously. And it's really important that children still have an understanding that time is something that really matters and they need to manage. And the final one is games. Now, there are so many different types of maths games that you can play, all games that just involve bits of maths as you go along. Board games are fantastic. Cards are brilliant as well. And there's a website later on that I'm going to suggest that has some ideas for games that you can play at home with your children. We live in a very digital age, and as I'm sure you know, much of our learning happens online. Now, there are so many great online resources. There are also many that aren't particularly good, and it takes a long time to get through all of them. So in the next 2 slides, I'm going to point you in the direction of some useful ones that I would recommend you have a look at. So the first thing is you will have been sent by your child's class teacher on Seesaw the curriculum overview. Now this will show all the topics that are being learnt in different lessons this term, and on the maths slide or on one of the other slides close enough to it, there will be some links for websites that can help with maths. So this could be a great place to start. Another website that we use in school, and every child has their own login for this, is called Times Table Rockstars. We mainly use it in years 3 to 6, but we're starting to use it in some year 2 classes as well. If your child doesn't know their login or you don't know it, you can contact your child's teacher and they can send it to you. But that's a great one for combining times table knowledge with some fun other aspects of online gaming. So please, I would highly recommend, if you want to focus on times tables, that's a great one to use. 5 minutes every day will make a difference. The next thing you can look at is some of the video links we put on some of our lessons on Seesaw. If you ask your child to show you what they've done in maths this week and click on the activities folder, when you look at the lesson activities in the instructions, there may be a link to a video for the lesson. Now, the way we teach maths in school is closely linked to a maths hub back in the UK called the White Rose Maths Hub, and they produce some really useful videos, and it shows very similar methods to the ones that we use in school. Occasionally, we use bits of these lessons in school as well, so the children should be used to those representations, but it's a great way for you to learn with your child to see what they've been doing at school and to practice some of those activities. Another online forum that you can use, which we don't use in school, but I do recommend if you're looking for some extra lessons or activities to use with your children, is called Khan Academy. It's completely free. I think you can sign up for it if you want a more personalized approach. Now it has videos, lessons and little assessments to support children through their learning of a range of topics. It's organised by year group, but just be aware it's an American grading system. So if it says 3rd grade, that means equivalent to our year 4, 4th grade is equivalent to our year 5, and so on. A good website we use quite a lot in school is called Top Marks, and it has lots of short and simple games that are great to play. Children can do most of these on their own. One of the games I would highly recommend is called Hit the Button Here, which works on times table facts, things like Numberbonds, many of the key sort of number fluency facts that children need to know. One of my favourite maths websites is called icymaths.com. And if you go on the website, there is a home learning menu that you can click on, which has some videos, some challenges, and some great games that you and your children can play together to develop their number confidence. Finally, a website I would recommend for anyone who is looking to do something a bit more arty in maths, something a bit more creative, something in a slightly different concept, or just looking for a challenge. It's called Wild Maths, and there are lots of different ways to explore and experiment with maths on that website. To access any of the independent websites that I've been speaking about on the last few slides, if you go back to the parent engagement flyer, that's the one that you clicked on to access this video, and down on the bottom right, just down here, we've got the links that you can click on to go straight to them. Up next, let's talk about times tables. Well, why are they so important? Firstly, what we find in school is it's one of the biggest factors that affects student confidence in maths, and that goes straight from early years all the way through to secondary school. And that's because it relates to so many topics: multiplication, of course, division, fractions, percentages, ratio, proportion, area, and many more. It's not part of the curriculum after year 4, which means that in year 5 and 6 and beyond, we don't specifically have to teach times tables. Now we try and embed them into lessons as much as possible. We've used them in home learning previously, but it isn't included in the time that we have anymore to teach in the curriculum. And that's a challenge for teachers and for pupils and for you guys at home. Now, they have to be practiced regularly and used in context if they're going to be meaningful and they're going to be remembered. I know that every summer holiday I have as a teacher, when I start back at school, I am slower at my times tables, and that's because I haven't been working on them for 6 weeks or so. So please practice them as regularly as possible. And on the next few slides, we're going to have a look at how we do it in school and how you can help at home. So to start with, times tables is all about making connections. Now, there's a commutative law of multiplication, which essentially means that when we multiply two numbers, you're going to get the same answer, whether you do 3 times 7 first or whether you do 7 times 3. It's always going to give you 21. Now we can use this to realize that, well, if we know our 3 times table, then we also know a multiplication in the 7 times table and in all the other times tables. For instance, if I know 3 times 8, then I know 8 times 3. If I know 3 times 7, or 3 times 9, or 3 times 11, or 3 times 12, I know 12 times 3. I know 11 times 3. I know 9 times 3. So rather than having 12 different times tables to learn with 12 facts in each, if we understand what commutativity means, then half the work is already done for us. Parents often say to me, oh, this isn't how I was taught it when I was at school, or I don't know the methods that you use at school. And what we need to do as teachers and as parents is find a balance between the two different ways. Now, times tables have traditionally been taught by rote learning, by reciting them, so that children can just instantly recall them. But it's also very important that they must understand the concept behind the maths and why it works. So on the next 2 slides, I'll show you how we teach times tables at school. And you can use some of these methods when you're working on them with your child at home. So in year 1 and 2, we start off by counting forwards and backwards in 2s, in 5s, in 10s, and then in year 2 in 3s and 4s. And it's about understanding the patterns and learning that multiplication, we do it because it is essentially repeated addition. We could do 2, add 2, add 2, add 2, add 2, or we could do 5 times 2. We want children to know and apply their multiplication and their division facts for the 2s, the 5s, and the 10s tables in these years. Some of the ways we look at that in school might be with number lines to start off with, showing the patterns as you go. We also use 100 squares. These are brilliant to look at times tables in a slightly broader concept. And here you can see highlighted in yellow, we've got the 2 times tables, and kids will notice that there's a pattern to these. You can discuss that pattern at home. We can see the 5 times table, and it makes it easier to recite them going forwards and backwards. The 10 times table is highlighted like this because it's part of the 10s and the 2s and the 5s. And there are some great 100 square resources that you can use online. If you just Google interactive 100 square, you'll find something very similar. Now, the other thing that we do in school is we focus on the language, because we don't just write maths, we talk about it as well. So instead of just saying 10 times 6, we might say 10 lots of 6 equals 60, and 10 groups of 6 are 60. We'll also remember the commutative law, where if 10 times 6 is 60, I also know 6 times 10 is 60. And then look at our division facts. Well, then I know 60 divided by 10 is 6, because division is just the opposite or inverse of multiplication, and 60 divided by 6 is 10. When your child can say all of these, then you know they have a really good secure knowledge of a times table. So please don't think about it's just one fact each time. Vary how you say it and how they represent the numbers. By the end of year 4, we want pupils to be able to instantly recall their multiplication and their division facts for all the times tables from the 2s up into the 12s. Now, this is a tough task, and we know that many children find it difficult. But the easiest way to get there is working as a team with teachers, with parents at home who are supporting, and with, of course, the student who needs to be aware of what they can do and what they need to work on next. We also want children to be able to apply these facts to other areas of maths. For instance, if they're doing 2-digit and 3-digit multiplication, but also to worded problems, to fractions, to percentages. We want them also to be able to multiply and divide by 10 and 100, which are closely related. One of the ways we do this in school is we will start to look at visual representations for multiplication. So here is a bar model. You can see the blue parts. There are 6 parts here. Each part is 3. So we could say 6 lots of 3 are 18. We also know that 3 times 6 is 18. And then we know that 18 divided by 6 is 3. You can see 18 is the whole amount. Underneath it is split into 6 equal parts. 1 part is 3. And we want children to look at the multiplication facts and division facts related to these pictures, but also then to apply it to maybe multiplications that could be 10 times bigger. So if I know that 3 times 6 is 18, I also know that 30 times 6 is 180. And 3 times 60 is also 180. In current times table lessons that we are teaching specifically in years 3 and year 4, they will see representations like this, which use what we call a 10 frame, because there are 10 spaces in here. Now, one of the methods we've been teaching children for the 9 times table is that they can first multiply by 10. So in the picture on the left, you can see 10 lots of 2. And then we can take away a 2 to leave us with 9 lots of 2. And that method can be applied to all of the 9 times table. So for instance, if you were doing 9 multiplied by 7, you could do 10 times 7 first of all, and then take away a 7. And we're working hard to try and help children understand these connections and then use them more regularly in their maths. In years 5 and 6, we take it up a gear, and we want the children to be able to frequently apply times table knowledge to any maths topic, and we want them to do that without having to be prompted. We also want them to multiply and divide by 10, 100, and 1,000. So, moving on from what they learnt in year 3 and 4, now we want them to be able to say, well, if I know, for instance, 3 times 6 is 18, then I also know all these other facts. We can now look at multiplications that involve numbers which are 100 times bigger or 1,000 times bigger. And we can do that in division as well. We can go into more detail with fractions. Remember, finding a third is just the same as dividing by 3. Finding a sixth is just the same as dividing by 6. We can also start to look at percentages. And we can go into decimal numbers as well. If I know that 3 times 6 is 18, then I know that 0.3 times 6 is 1.8. One of the parts I'm multiplying is 10 times smaller, so my answer is also 10 times smaller. The other thing we do with times tables in these year groups is we really start applying them to worded problems. And we're using that with visual representations as well. So in this example, we've got 360 children who go on a school trip to Motion Gate. The children were equally split into 9 buses. So you can see we've got the 360 children in total, and the bar representing those 360 children is split into 9 equal parts. So we might say, well, what fraction of the children were on one bus? Well, if it's split into 9 equal parts, that must be 1/9. How many children were on one bus? What's 1/9 of 360? And we want children to remember, well, finding a 9th is the same as dividing by 9. And they should notice that 360 is related to the number 36, which is in the 9 times table. So if they know that 36 divided by 9 is 4, they also know 360 divided by 9 is 40. So there must have been 40 children on one bus, and so on. So what can you do at home to help make a difference and support your child alongside us in their learning of their times tables? Well, there's many things. But the biggest thing is please practice little and often. Now, 5 minutes a day would be perfect. Even 2 minutes a day would make a massive difference. And you can do this anytime. In the car, walking to school, going shopping, it doesn't matter. Fit it in wherever possible. Use variety when you're working with your child as well. Don't just keep saying the times tables in the same way. You could give missing number questions such as 48 divided by something is 6. Also try and make it real, make it practical. Look at how we use multiplication in real life. In these examples that I'm given here, shoes come in pairs. You have 4 pairs, how many shoes do you have? That's relating to the 4 times table and the 2 times table. Also to do with cooking, when you're scaling recipes, we only need a quarter of this. How much is that? Well, a quarter is the same as dividing by 4. So can we use the 4 times table to help? Also, learn with them. Now, as I said before, how you may have been taught your times tables may be different to how your child learned. So ask them, how did school teach you to multiply by 12 or by 9? What easy methods do you know? Can you teach me a great trick? Games are great as well. The online games Times Table Rockstars and Hit the Button, again, I highly recommend. Encourage your child as much as possible, set them targets, and celebrate their little achievements. Now, those last 3 are pretty obvious and a normal part of parenting, but it's so important to remember to do this while we're learning our maths as well. Now let's look at what we call number bonds. Now, this is vital in years 1 and 2, that children understand the concept that 2 numbers can fit together to make another number. Now, when we think of our number bonds, what we mean as teachers is that we really mean things like number bonds to 10. So two numbers that fit together or can be added together to make 10. But we do also go on to think about number bonds to 20, number bonds to 50, number bonds to 100, number bonds to 1,000. We can look at number bonds to 15, to 16, and lots of different strategies and, I guess, mathematical concepts that are involved in quickly adding those two numbers or seeing the connections between them. So in year 1 and 2, it's really important to build a good foundation. But these kind of skills do get applied throughout all of our mathematical learning at school. So let's start off simply with how can 10 be made from two different numbers? Now, we don't just look at this from an abstract way, writing the digits down. In school, we'll use physical resources that can be touched and moved, or in these troubled times at the moment, often we'll show digital representations. Now, one of my favourites for teaching number bonds is called Numicon. And these are pieces where the number is represented by the number of holes in the piece. So you can see here we've got 3 and 7, but when we add these two parts together, they form a perfect rectangle of 10. Very similar to the 10 frame representation that I showed before. We've got 10 equal parts in it. And it's a great resource for children to explore. We also use Dean's cubes, which are sometimes called base 10 at school. So here we can see we've got 4 cubes. If we add that to 6 cubes, if you stack them up, they would make a 10, which looks like this. And in school, we have resources which are one piece, which is a 10, which is exactly the same size as these. So it's a great resource for children understanding the size of numbers and how they fit together. We might also look at it in what we call a part-whole model. Similar to the bar model, we have one part here and another part here, and we add them together to find the whole amount up here. And we could represent that with digits or with pictures or with a mixture of the two. And back to the 10 frame, which I think, again, is probably my go-to resource for looking at number bonds. Now, I can highly recommend you could draw these out, you could print them out, and I've used red and yellow counters in this one to show that 2 add 8 equals 10. And children will know that it makes 10 because there is a counter in each of the 10 spaces on the 10 frame. A brilliant way at home you can start to get physical with 10 frames is to use an egg box, like in the picture over here on the right. So this person has taken an egg box. Now they've written the numbers in up to 10. You can do that if you want, you don't have to. And I love the way that they've chosen some blueberries to put in as counters. So in this representation, you can see they put 2 blueberries in. So we've got 2 is one of the parts, and the missing part, we've got 1, 2, 3 spaces on the top, we've got 5 on the bottom, so this shows that 2 add 8 equals 10. And you can see that again in the 10 frame representation over here. But I love this method because it makes it physical, and what's great here is that children can actually touch and move the maths as it happens. Now, as well as just playing around with it and doing it, we want them then to start writing the calculations. And a bit like the part-whole model and the bar model, it's great here to talk about parts and the whole amount. So because we're using a 10 frame, when it's full, the whole amount is always 10. And we can think about the parts that we're using. So in the red and yellow example above, we've got 2 red parts and we've got 8 yellow parts. So 2 plus 8 equals 10. We can also look at it starting with the yellow part. We could say 8 plus 2 equals 10. And it's important, again, for children to understand, very similar to multiplication, we can move the numbers around or move the parts around, but if we're adding them, we're still going to get the same answer here. Then we move on to the principle of subtraction. Let's start with the whole amount. Well, if the whole amount is 10 and we subtract 8 from it, how much are we left with? 2. Why are we left with 2? Well, because I know that 2 and 8 are number bonds to 10. And again, we can see the other subtraction calculation. 10 subtract 2 equals 8. And so when children learn their number bonds, they should be able to say, well, if you give them the number 3, they can say 3 and 7 makes 10. And you can say, can you write the 4 calculations for that? And can you giving me 2 additions and 2 subtractions? So they should also know that 7 plus 3 equals 10, and that 10 subtract 7 equals 3, and 10 subtract 3 equals 7. Now, as we move into later years, we take it one step further. So if children know that 2 plus 8 equals 10, in year 2, we start to get them realizing that, well, 20 plus 80 equals 100. And then moving on into year 3, well, if I know this, then I also know 200 plus 800 equals 1000. And then onto years 4, 5, and 6, we start looking at decimals. And if children have a really strong sense of their number bonds, it's very easy for them to make the jump to see that 0.8 plus 0.2 is going to be 1, because 0.8 is 10 times smaller than 8, 0.2 is 10 times smaller than 2, and 1 is 10 times smaller than 10. So moving on even further with our number bonds, in this example, we can see 2 number bonds to 10 are 6 and 4, because 6 plus 4 equals 10. But then we also want children to think about, how does that help us with our number bonds to 20? Well, in this case, we should be able to work out that 16 plus 4 equals 10. I've added a 10 to 6 to make it 16, but the other part that we know fits with 6 is 4. So this will make the next 10 up, which is 20. And we start to discuss and develop that relationship in school. And it's great to practice that at home as well. Again, if you were using egg boxes, you could just use 2 egg boxes to make 2 10 frames instead, which would give you 20 as your whole amount. Now, if children get pretty secure on their number bonds, then they can start using them to calculate numbers like this mentally. So 46 add 54 equals 100. Again, we're still using our knowledge of 6 plus 4 equals 10, and then we know 40 and 50 and 90, so in total I have 100. We can then apply this to even bigger numbers. 60 and 40 are going to make 100. How do you know that? Well, I know 6 and 4 make 10, and so on. And then it ends up with children being able to do mental calculations like this quite quickly, because they'll notice, oh, 6 and 4 are number bonds, and then the other numbers I can add up quite easily. Another way to look at our number bonds is when we have calculations such as this. Now, children will know that 6 and 7 don't fit together to make 10. They're not number bonds to 10. But we can be clever here. Now, if we partition 7, meaning if we split it up into 4 and into 3, we could ask a child, how does that help us? And we want them to notice that, well, oh, I know that 16 and 4 makes 20. And then I've just got to add on 3 to the 20, and that gives me our total of 23. And the more practice of things we do like this with them, the better their mental calculations become. So how can you work on number bonds with your child at home? Well, it's very similar to what we said about times tables. And it's all about practicing frequently. Just a little bit every day would make a big difference. And again, you can do that while you're in the car, while you're walking to school, wherever. Again, use variety. Don't just keep asking in the same way. So 20 is made from 13 and what? Those kind of missing number questions are brilliant again. Please make it real as much as possible. We've only got 3 apples left in the house. We need 10 for the week. How many more are we going to need to buy when we go shopping? Learn with them. So again, ask them questions about how they have learnt it at school. Use the representations that I showed on the last couple of slides. and do some learning with them. You can use some games as well, and Hit the Button that I mentioned previously is a great game to play for your Numberbonds practice. And then of course it's about the encouragement, the targets, and celebrating those little achievements. Last week you couldn't remember how to do this, and this week you're getting it every day. Brilliant work. We're now coming towards the end of our session, and I hope that at least one bit of the advice or information that I've given you will be really useful at home in supporting your child's maths development. But I wanted to leave you with one of my favourite top tips for calculating, and this is called the same difference subtraction method. Now, some children in Year 5 and Year 6 may have used this in lessons, but it's a great one to know and to practice at home. Now, whenever I teach calculation, I always want to put it in a context to make it real. So the context of this subtraction is about Mr. Sadler, and he's laying some grass in his garden. Now, I've used the numbers 10 meters and 2.37 meters. So this question is more appropriate for Year 5 and Year 6 children. However, if you wanted to try it with your child and simplify it to maybe 100 of something and then 23 of something, you could do, and you can change the context however you want. So the problem is Mr. Sadler is laying new artificial grass in his garden. The length of the garden is 10 meters. However, he needs to leave a 2.37 meter gap at the end for his barbecue area. What length strips of grass does he need? Now, after discussing this with your child and maybe drawing a picture of the 10-meter strip of grass and then dividing it and showing how big a 2.37 meter cut off the end would be, then you might come to the conclusion that, okay, this is a subtraction. We've got to think about the 10 meters and we're subtracting that 2.37 meter part off the end of it. And then we'll know how long the strips of grass should be. So lots of children will say, okay, we're doing subtraction. I've got 10, it's decimal numbers. So I've got my 10ths column and my 100ths column, and they're going to do a formal method that we will call column subtraction like this. Now, if they use this method, they're going to end up with what we call exchanging in school, which essentially means, well, I can't do 0 take away 7, so I'm going to exchange from the other columns. And in this question, because we've got a 0 in the 10ths and in the 1s, and then we've got a 1 in the 10s column, there's going to be a lot of exchanging to do as we go back. But if we use the same difference subtraction method, we have a quick way around this. Have a look on the next slide. So first of all, we want children to understand that subtraction is all about finding the difference between two numbers, and we can demonstrate this brilliantly on a number line. So by subtracting 2.37 from 10.00, we are finding the difference between the two numbers, 10.00 being the bigger number. Okay? In the same difference subtraction method, we think, well, okay, let's adapt those numbers just slightly, but we're going to keep the difference the same. So 10.00 is going to become 9.99 by taking 1/100th off. And I'm going to do exactly the same to 2.37. I'm going to take 1/100th off there and make that 2.36. Now the difference in these numbers will be exactly the same. So because subtraction means finding the difference, and we've now kept the difference between the two numbers the same, if we complete the calculation using 9.99 and 2.36, our answer will be the same because the difference is the same. So now we can use our formal column method to complete this, which involves no exchanging whatsoever and is much easier. Simples. We've now come to the end of the session, and firstly, I want to thank you so much for taking the time to watch this. I really hope that there's some useful tips and advice that you can use to help support your child better at home. And we all know that with parents and teachers and students working together, it's going to give your child the best chance of making great progress. Don't forget that on the parent engagement flyer, there are the links to the maths websites, and please remember that you can access this video at any time, pausing it as you go to look back at some of the methods that we have talked about. If you need any more support with maths at home, please contact your child's class teacher, and if necessary, they can get in touch with me. We would love to hear about what you've been doing, and if you have tried any of the methods together that we've talked about in this video and your child is making great progress, please send in some pictures or a little video and post it on Seesaw. Thank you very much and take care.